Hey there, it's your old pal, Mr. Cook, and we're just getting through this review. So we're up to number 4 now, and this one's about the average rate of change, the mean value theorem, and I guess that's about it. Well, potentially Rolle's theorem, and we'll talk about that in a second. Okay, so with number 4, part A, it says find the average rate of change of this interval over here. So average rate of change is a formula, and it's kind of like the evolution of a slope, okay? So when we had linear equations only, we had a slope, and here's the slope formula. If we had two coordinates, y2 minus y1 over x2 minus x1, right? But that's for lines, for linear equations, and it works real well. But the same equation, what we're going to do is now call it the average rate of change, right? Not the slope any longer, the average rate of change, because we're dealing with more than just lines. This can be any function. And instead of just using y values, individual coordinates, to give us like this average rate of change, we're going to use the functions, okay? So it's going to be f of, some value, let's call it b, and then f of a on the other one. And the x values that we're going to use are b and a. So the way that I get these b and a values is from this interval over here, that I've established. So the average rate of change problem will always go in the following way. You're going to be given a function, and you're also going to be given an interval, okay? So you just need to basically remember the formula to get, that average rate of change for that function. Okay, so let's translate this into the stuff that we have. The average rate of change for this function over the interval 1 to 4 will look something like this. So if I take the g function and I plug in the b value, which is like the last value in my endpoint 4, this is going to give me some y value, right? So I'm going to subtract away the other y value for the endpoint. So that's going to be g of 1. And then I'm going to divide that by the difference of the x values that I'm using. Okay, so now I just plug those numbers in. Let's see what we actually get here. G of 4. So I use the g function over here. G of 4 is going to be equal to 4 over 4 plus 2. So that's 4/6, which would be equal to 2/3. So 2/3 is my first number. And then if I plug in 1 for the g function, that'll be g of 1. That's going to be 1 over 1 plus 2, which is 1/3. And they're subtracting, right? Yep, subtracting. And then over 4 minus 1, which is 3. Okay, so now let's work through our average rate of change. Let's see what we've got. So 2/3 minus 1/3 is 1/3. And then I've got to divide it by 3. Now, when I have a fraction divided by a number, what happens is that these numbers just multiply. So this is going to be 1 over 9 for my average rate of change. All right, so that's part A. The average rate of change is 1/9. Now we do part B. So part B, let me read it aloud. So show that the mean value theorem, or Rolle's theorem, guarantees a time value with a time value with, because we're using t, a time value within the interval from 1 to 4, where the instantaneous rate of change equals the average rate of change. So you should know this, vocabulary or this phrase, instantaneous rate of change. Instantaneous rate of change means the derivative. And in this mean value theorem will guarantee that this is true, that over that interval, there's a place where the derivative is equal to the average rate of change if you meet two conditions. So the first condition is that you need to make sure that the function that you're working with, so in this case it's g of t, is continuous over the interval. And we just write 1 and 4. So the function is continuous over the interval. And we can actually prove that this is true if you need some clarification. It's because if we look at this function, what is the domain of the function? Well, the only bad part about this, t can be anything that it wants up top, but in the bottom, t is not allowed to be equal to -2, because if it is, that'll make 0 in the bottom, and we do not want to divide by 0. So my domain is that t is not going to be equal to -2, okay, overall. But -2, if you notice, is not in this interval. So that means that it's going to be continuous everywhere, okay? So t can't be equal to -2, but -2 is not even in this interval from 1 to 4 for t. Okay, so that's the proof for it as well. The second part is that g of t is going to be differentiable over the open interval. So 1 to 4. And the reason that it needs to just be the open interval is because it actually doesn't matter what happens at the ends because it's the limit. As long as the limit on the right-hand side and the left-hand side of those intervals are okay, then it's going to work out. And you can actually show that this function is differentiable over that interval by actually finding the derivative. And you know what? Let's explore this a little bit because these are the two conditions that you need to make, that you need to write down, and we're okay there. But I'm going to actually prove that the derivative, that this function is differentiable over this interval by taking the derivative. Because if you look in part C, it says find the actual time where the derivative, the instantaneous rate of change, is equal to the average rate of change. Now, I've already got the average rate of change. I know that that's 1/9. So I still need to find the derivative of this function. So g prime of t. So I haven't found it. So let's just do it, over here, because then it'll allow us to kind of use it to reinforce the fact that this is going to be differentiable. So all right. So the first derivative of t looks like I've got a function over another function. So I'd use the quotient rule here. So low d high, so low function. The derivative of t is just 1 minus high d low, so t times the derivative of the bottom function, which is just 1, all over the low part squared. Looks like I can simplify this a good amount because t plus 2 times 1, that's just the same as saying t plus 2. That's not that crazy. And then negative t times 1 is just negative t. And I can simplify this a little bit further because I've got a t and a negative t here. So they just cancel out, right? They add to 0. So that means that this is my derivative, 2 over t plus 2. So where's the only place that I can't find a derivative? I can use any t value that I want except for one value in here, right? T is not allowed to be equal to negative 2. But again, is negative 2 in the interval, the closed interval or the open interval? No, it's not. So that means that it's going to be differentiable anywhere. Other than that, it's differentiable in the interval. Okay, so now that I found my derivative function, I can plug that in over here for part C. So it's going to be 2 over t plus 2 squared. And then whenever you have a fraction equal to another fraction, you got to solve. You always use the same steps, and that's going to be cross multiplication. So if I cross multiply this stuff, here's what I get. I get 1 times t plus 2 squared, so t plus 2 squared is equal to 9 times 2, which is 18. And now I start my solving algorithm. So I got to get the t by itself, so I undo the square, so I square root both sides. So t plus 2 is equal to the square root of 18. And whenever you take the square root of a squared variable, okay, so squared t in this case, you have to have a plus or minus out in front there, okay? All right, now let's get t all by itself. Let me get rid of that square root so it's not confusing. But now I got to get t by itself, so I'm going to subtract 2 from both sides. So t is equal to negative 2 plus or minus the square root of 18. But both of these numbers, they might get us a derivative that gives us a 1/9. That's true. But remember that, that the value that we're looking for from the mean value theorem needs to be in the interval from 1 to 4, right? So t is in 1 to 4. And if you look at these two numbers that we get here, we either have negative 2 plus the square root of 18 or negative 2 minus the square root of 18. So this is obviously not the choice, right? Because that's going to be a negative number. And there's no way a negative number can be in there. So that means that the number that we're looking for is this one right over here. That is the t value that gives us an average rate of change equal to the instantaneous rate of change. Okay, I think that's it for this video. I went on long enough, I think, for it. So I hope you got something out of it. If you need some help, go talk to your teacher. I'll make a couple more videos going over these limits. Hope to see you then. All right, bye-bye. Have a nice day.